This lesson is going to be on writing linear functions from different situations. Before we start, we're going to review the different forms. Standard form, we have ax plus by is equal to c. And in standard forms, there's going to be no fractions. None of our terms, none of our coefficients can be fractions. Point slope form is y minus y1 equals m parentheses x minus x1. In point slope form, we can identify a point, which is going to be our x1, y1, and we can identify the slope, which is the m. Slope intercept form is y equals mx plus b. From slope intercept form, we can identify the slope and the y-intercept. The slope is still m, and the y-intercept is b. Write an equation of the following graph in all forms. So we have a graph. I'm going to start by writing it in slope-intercept form. The reason why I'm starting with slope-intercept form is because from the graph I can easily find the slope and find the intercept. To find the intercept, I'm going to determine where it crosses the y-axis. So my graph crosses the y-axis here at 0, so my y-intercept is 0. Now to find the slope, I'm going to pick another point. I have a point down here, and I'm going to see how much I have to move up or down, and then how much to the right. So I have to move down 5 units, that's a -5, and then to the right 3. So my slope is -5/3. So my equation slope-intercept form is y equals -5/3 x plus 0. Or I just write that as y equals -5/3 x. Now my point slope form, I have a point. I can use this same point here, which is 3, -5. And I have my slope of -5/3. So my point slope form would be y plus 5, because I do the opposite, equals -5/3 parentheses x minus 3. And then my standard form, I'm going to take my slope-intercept form of y equals -5/3 x and isolate the constant. So I'm going to add 5/3 x to both sides. So I have 5/3 x plus y equals 0. And now I don't want any fractions, so I'm going to multiply by my denominator of 3. And that leaves me with 5x plus 3y is equal to 0. Write the equation of this graph in any form. Since it's a graph, I like to use slope-intercept form. So I'm going to write my equation in slope-intercept form. My intercept, my y-intercept, is where it crosses the y-axis, which is at 2. Now for my slope, I have to pick another point. I'm going to pick this point up here. I move up 3, so that's a +3, and to the right 1. So my slope is 3. So my equation would be y equals 3x plus 2 in slope-intercept form. Determine if this table represents a linear relationship. If yes, write the equation in slope-intercept form. So first I'm going to see how the y is changing. All my y's are changing by subtracting 3. My x's are changing by adding 1. So since I have the same changes, that means it is linear, and I can use those changes to determine my slope. My slope is a change in y over change in x. So that's -3 over +1, or just -3. Now I have to find my intercept, my y-intercept. There's a few different ways I could do this. The first way is to determine where my x is 0. So when x is 0, the y value is your y-intercept. So I can work backwards in my table to determine when x is 0. So since I was adding 1, now I'm going to subtract 1. And since I was subtracting 3 to go to the right, to go backwards, I'm going to add 3. So that's going to put me at 1, negative 8. Then I have to go back again, subtract 1. Now add 3 again, and negative 8 plus 3 is negative 5. So my y-intercept is negative 5. So my slope-intercept equation would be y equals negative 3x minus 5. Another way I could find the y-intercept is to set up my equation of y equals negative 3x plus b. And now I'm going to use one of my points, the 2, negative 11, and substitute that into my equation. So I'd have negative 11 equals negative 3 times 2 plus b. Negative 11 equals negative 6 plus b. And when I add 6 to both sides, I have negative 5 equals b. And a third way I could do this problem is I could write my equation in point-slope form. I'm going to use the same point, so I have y plus 11 equals negative 3 times x minus 2. When I distribute, I have y plus 11 equals negative 3x plus 6. And when I subtract 11, I have y equals negative 3x minus 5. So 3 different ways, all leading me to the same answer. Same type of question. So I notice my y's are increasing by 1 to start, but then they're increasing by 2. If my x's are not changing the way they're increasing, then this is not linear. So since I add 2 to start, but then I continue to add 2, so here my slope would be 1 over 2, but at the end of my table, my slope would be 2 over 2, which is 1. Since they're not the same, this table is not linear, so I cannot write the equation of this linear table because it's not linear. Write the equation of the line in all forms. So first, since I have the points, I'm going to find the slope. I have x1, y1, x2, y2. So I have 4 minus negative 1 over negative 2 minus 2. 4 minus negative 1 is 5. Negative 2 minus 2 is 4. So my slope is negative 5/4. Since I have my point and slope, I'm going to start with my point-slope form. I have y plus 1 equals negative 5 over 4 times x minus 2. So that's my point-slope form. Now I'm going to use this to find my slope-intercept form. I'm going to distribute, and I have y plus 1 equals negative 5/4 x plus 2.5. Subtract 1 from both sides. Y equals negative 5/4 x plus 1.5. And now for standard form, I'm going to get the constant by itself by adding 5 over 4x to both sides. So it gives me 5 over 4x plus y equals 1.5. Multiply everything by 4, so I have 5x plus 4y is equal to 6. So this is my point-slope form. This is my slope-intercept form. And this is my standard form. And test 6, write the equation slope-intercept form. So I'm going to first find my slope. So I have negative 4 minus negative 4 over negative 1 minus 0. 0 over negative 1 gives me 0. So since my slope is 0, I have y equals 0x. And since I have a point where x is 0, negative 4 is my y-intercept. And I don't have to write the 0x, so it's just y equals negative 4. And I could have known that from the beginning because I noticed both of my y values are the same. So that's why it would be y equals negative 4.